Then the same thing is for the causal loop diagram, right? So the causal loop diagram is like this. So it's also in the picture. So firstly, I can click here. I say like what the example that we showed just now, right? Birth, population, and death. And then I put in the arrow here. And then I can build my system diagram. Now, because we got reinforcing and balancing loop, so what we need to do is then to add in there's a birth rate and death rate, right? And then we can color it, change the color whatever way you want. And then we put the polarity, is it plus or minus, okay? And so step through, so now we are done, okay? So this is a positive, this is a positive, this is a reinforcing loop. Dev is definitely trying to do a balancing loop, okay? Plus and minus. All right, and then since it's a reinforcing loop, we can put a R there, right? So there's a R here, which I can put here. So now I know that this loop is R, and then I put a balancing loop, and I put B. So now it's very clear. When you see the diagram, everything is picture is very, very nice. Okay? All right, so you can do this exercise at home. All right, so, okay, good. Let's see what time it is now. So it's 11, it's going to be 12. Actually, when you do this exercise, it'll take you 1 hour. So we got half an hour extra. Okay, never mind. I can always do a little bit more. All right, let's talk about the system model. Okay, can So don't need to download, go back, download, get the slides. Then I will talk a little bit about business model, okay? Now, once we learn the concept, there's the first part is this. Oh, by the way, we are at part 1. We got part 1, part 2, part 3. We are at part 1 only. We just finished part 1. If you have done your simulation, then you will do your simulation until you finish part 1, okay? So we're going to part 2, the purpose, process, and the structure, right? So the purpose of modeling. Okay, so when we say what's the most important people in the safe operation of the aircraft, a lot of people say it's pilot. Actually, it's the designer. So you are the designer. So you must make sure that when people use the system, you design it properly.
Dangerous person.
Huh?
The most dangerous.
The most dangerous person is who? Is the pilot. Wrong, I'm a pilot.
Yes, it's the most dangerous one.
Oh, the most risk-averse person is the pilot, actually. Do you know? The most reckless. The most reckless person is the car driver.
Nut that is holding the wheel.
Okay.
The nut that is holding the wheel.
Let me tell you a bit, because I also train CEOs using the pilot analogy. Okay. Pilot training goes this way. When I was under training, right, we have to memorize. Because you see the airline pilot, they never memorize anything because they always checklist. Okay. But when we are training on small little Cessna, we memorize everything, right? We are like robots basically. So what happened is before we go for a flight, the first thing we step into the office, right? Pre-flight, we call it pre-flight. We check, we do NOTAM, notice to airman. The notice to airman is say, don't fly over Ukraine. Like that lah. Or today air show, at this time shut down, that kind of airspace shut down. We need to know exactly what's the environment. Correct? Which driver do that?
Some drivers.
You may check weather only, that's about it. Huh? So we have to then.
Google Map. Which one?
Yes. No, that's what we call pre-flight check. We know exactly where we are, right? So the Google Map. Nowadays, last time also never. But then, when you walk to the aircraft, what happened? What do you think? When you walk to the car, what do you think? What have you done? What are you doing? Check tire pressure. Tire pressure. When who scratched my car? Yeah. Do you ever do that? You see, when a pilot walks to the aircraft, the first thing is that we look at the surrounding already. We look at who are the people standing by, how many aircraft next to my aircraft, All right, then very far I look at the wheel, right? I look at the wheel, the choke in place or not. Any oil spill. You scrutinize everything when you are looking. There are at least 10 items to check when we are walking. We walk to the car, you ever check? Somebody drive out, hey, flat tire. Most of the time, right? Then this is something that you probably see in a movie, which is you open the door, you turn on what you call the master switch. You turn on the master switch, which is the power up, right? Then the first thing is you walk around the aircraft, right? You walk around the aircraft, you check the wheel, the tread, right? Whether it's ball or not ball. Who in the car check whether the tread is ball or not ball? We don't do. Check the tread is ball or not ball. Check the wings, check the propeller got crack or not. Got hairline crack or not. Check all the temperature probes, whether it's blocked or not. Then check the fuel, whether got water or not. So we have to pull out the fuel and normally we have a small little container. You plug in and see, got water in the fuel or not, because overnight condensation, right? Water in the fuel, go in the engine will shut down. So we check everything. Do you ever check whether your car behind the boot up or not? No, nobody check this. At least this one got 20 items to check. After you sit in the aircraft, you check all the control surface, whether it move or not. Right? And then you turn on the engine, you check engine temperature, oil, air pressure, everything, right? When we drive a car, drive. So, pilot is the most risk-averse person in the world. Everything you do, you check. And then when you're flying, every 15 minutes you need to do a check, engine check. It's quite easy. Temperature, all the knots are in green color, right? That means we check everyone, and there's a pattern, we swing through. Okay, nowadays everything is simple because it's multifunctional display, right? Last time when I was trained, right, it's like at least 20 over equipment to check. You have to have a pattern of scanning, up, down, up, down, up, down, up, down. Yeah. So, pilot is the most risk-averse person in the world. And our test is so precise. You know that when we land the aircraft, there's a runway threshold, right? A lot of slots, and then there's 1 slot, 2 slot, right? So every one slot is 500 feet. 500 feet and 500 feet. Then you tell the tester, I aim here. 500 feet of the threshold, I will land. Okay? You allow, I think 100 feet above and below. That's it, right? When you land, you exit, you know what happened? You fail. You land very precisely. Yeah, so we land, so our control skills are actually very, very good. So that's how we train. So therefore, I passed my flying test first time. I failed my driving test 5 times. Driving in Singapore, very difficult pass. But flying test 1 time pass. We are all super precise. So the interesting thing is there is this research project in Harvard. When I was in Harvard and I was talking to them, and then I create a course. So what happened is the pilot mindset, with the way you train pilot, the CEO who are pilot, the company tends to be more innovative. So we say, are they more risk-taking? Actually, they are not, because we know where's our envelope. Pilot will know where's we study our aircraft, right? We know how fast, how high we can go, how much pressure the wing can take.
All CEOs go for pilot.
Yeah, that's true.
All CEOs go for pilot.
Yeah. So I tell you the reason why. I tell you what the research do, right? We understand our boundary. Okay, pilot understand the boundary. It's like a system, right? We understand the boundary conditions. And when we start understand the boundary condition, we'll never exceed the boundary conditions. So when we do flight planning, right? We do path by path by path by path, right? We will make sure that we will never exceed the boundary condition, and we simulate all kinds of potential environment. That's why pilot always go to simulator, right? Because I do not know what happens, so I train myself on simulator, and then all weather, lightning, all kind of things, just throw in the worst situation to whether I will exit boundary. And therefore, in all kinds of scenarios, I can handle, which means it's like you take a motorbike and go for the wet driving course, right? Or dangerous driving or whatever, extreme driving course. pilot is actually going there all around. We have been doing it daily. So therefore, when anything happens, we can handle because it's automatic. All right. So therefore, then when a CEO who is a pilot, right, the mindset tends to be, I actually simulate all possible scenarios already. So when he run a company, he want to take a risk or whatever innovation. He knows where's the boundary. He simulate all scenarios and he go. That's why tendency, you see the SMEs who are CEO who are pilot now, their patents are very high. Their products, new products are very high. It's the training of the mindset. Yeah. So I have a course which I conducted 3 years ago at the Flying Club, which is just opposite, right? Where the CEO comes and we bring them up to fly. Not to train them to pilot, but to then understand. Then we bring them down to do the simulator and let them plan all. This is my business plan, right? My vision, right? From here to there. And then after that, we inject scenarios in the simulator so that he planned the scenario like fight plus and inject thunderstorm, inject this, until he get himself familiar with all possible scenarios. And therefore, when he execute business plan, he knows how to handle all possible scenarios, which means simulator is very good. Okay? Yeah, that's my pilot story. Okay. All right, so therefore, the virtual world, which is a simulator, provides us an important tool for managing the structure, right? So if you are the client, I'm the modeler, right? So client can be any stakeholders, and modelers must focus on client needs, which is the real world thing. Let's look at the process of modeling. Okay? These are something not very so-called sophisticated. I mean, decision solving process are still there, right? So first, problem articulation. What's the problem? Then hypothesis. So once you have the hypothesis, you formulate the model. And hypothesis is causal factor, right? What link? That's hypothesis, causal factor. Then you build your model, you test it, and then see whether you need to change the policy. Okay? All right? So it's very simple. So what we're trying to do is to model the real world. So as far as the real world is concerned, you should start with something simple. What are the major perturbations in the real world? And then after that, you then slowly add in things when they are comfortable, right? So you test it in the real world, then you have information feedback, and then you decide your strategy and structure. Okay, probably these are very management talk, right? So first, problem articulation, right? What is the problem? Why is it a problem? And then identify the key variables, which you all have done already, specify the time horizon, and then roughly in your mind, what's the behavior of the system? Okay, once you have the behavior of the system, then you can formulate a hypothesis. All right? The buzzword of endogenous and exogenous. Okay? Now, endogenous means things are happening inside the system. Exogenous means external influence. So when we first model, we don't try to put too much external influence. We try to say things are all internal driven. So because that's your modeling, you're trying to model the real world. Okay? So don't try to put in too many external variables. So you map, get a specification, and all the estimation, and do the testing. That's how you formulate those. These are the what you call the variables and the equations. Okay, and then you compare to reference model. And one thing you want to do is extreme conditions. Okay, it's like software testing lah. Software testing, you always want to test boundary, right? Inside, on, and outside the boundary. Right? Inside, on the boundary, outside the boundary. Okay? So it's the similar. And then after that, policy design. What if, sensitivity analysis. This is depending on whether you are rolling out under what situation. Okay? Yeah. So example, what's the problem? Where is my market share falling? Okay? Then key variables, what's the outcomes? Market share falling is market share, fail, profit, market share drops, quality drops, or whatever. Decisions, what's the decision on price and production? Time horizon, number of years, and then the dynamic problem definition. Okay, you start drawing the curve. All right? So If you want growth, then you must use reinforcing loop, one or more reinforcing loop. So if you are designing for growth, start with the growth loop. And then try to identify the balancing loop so to make it the system stable. Okay? All decisions, rule of thumb, is represented by the balancing loop. So cannot keep growth forever, right? So decision variables connected to the variables that you wish to change, make it part of your balancing loop. All right, so the structure, okay, these are the interesting stuff, right? This what we call system archetypes. System archetypes are reference model. It's the architecture, right? So when we do design thinking, we have persona, correct? The persona are your archetypes. It's your reference model that represent a population, okay? A market segment or group of users. System archetype is a reference model that represent a certain behavior. Okay, right? So persona represent a user when you empathy, user group. System archetype, persona or what they call, persona is also known as archetype. What's the exact name? Don't know. It's just archetype. Then the system archetype represent a system behavior, and this is the few. I think there were 6 basic behavior. All right, and you learn already because you learn the reinforcing loop, right? So if you're looking for exponential growth or decay, you are looking for the balancing loop. So it's in a way it's to tell you if your objective is this, then use this and plug in. You're more or less can start designing this. Don't need to think too much, right? It's the reference model, right? So the description exponential growth, right? Basically reinforcing. If you are goal seeking, you try to seek a goal. You try to reach a goal, right? Which means you are balancing, reach a stable point. So that itself, right? So the goal seeking behavior is a balancing process to use a gap between a goal and the actual condition, right? So you see, this is a corrective action. You can see what is called you have a S and you have a B, right? You have a sustained 2S, and 1 O, right? So it should be a balancing loop, right? That one is not, the R is not right. Okay, then you have oscillation. So when do you apply oscillation? Seasonal, right? It's like semester, student come in, student not disappear, right? Or you apply like winter season, summer season, sales go up, shares. Okay, you must think about environment, whether you have such thing, right? So if seasonal, that means what? Winter season, you produce more winter clothing, that's seasonal, okay? So it depends on what trade and business you are in, right? So this is the reference model, okay? Now things, and then you come down, right? Now you have 2 loops come together, right? From one single loop to 2 loops, you have a reinforcing and balance. The reinforce will push it up, and the balance will stabilize it. All right. So once you see the behavior, you know this is the model to just plug in and use, right? I mean, you're not familiar, just throw in the simulator and then see the graph. Don't need to think too much about it, right? Just key into the computer and see the simulation. Now, more complicated stuff. If you have downward simulation, upward oscillation, you start combining the reinforcing loop and the balancing loop together. Together, sometimes crossover, sometimes inside, sometimes mixing. All right? My advice is don't try this type of thing. If you're at the first start, try the simple one. Okay? These are more sophisticated, advanced user, right? But I have put it here, which is very simple for you. I extract some of the system archetype. First, important thing is look at the graph. Don't look at the system diagram. You like look at it and you're like confused. Look at the graph. This is the output that you want, and then look at the storyline, because everything is easier if you tell a story. Look at what this story is all about, right? So if I can just look here, right? The storyline, the drifting goals archetype, right, is that there's a gap between the goal and the actual condition can be resolved in two ways, by taking corrective action to achieve the goal or by lowering the goal. So you hypothesize wherever there's a gap between the goal and the actual, the goal is to lower, to close the gap over time, right? So once you understand that storyline, then you can then say, okay, I can now use the archetype, right? The reference model. Okay? And then there is the other option. So I give you a lot of things for you to reference. But when you first started, don't try all this stuff. Okay. Okay, the storyline, once you choose the graph, right, then I also give you, if you choose the graph, then what are the steps, right? So there are two pictures, right? One is the picture, the final output, then what's the story you want to tell, and after that, your story you want to tell, then what are the steps? Identify the growth engines, determine the doubling line of process, and that's the step of building the thing, right? But the way to look at it is application is also to look at the title. Say limits to success, shifting the burden or whatever. Okay. So for these type of things, later on when you are more advanced stage, then you look at it. Okay. All right. We still have time. Let's take a simple thing, simple case of design, right? A practice case. Okay. We're looking at managing a project. Okay. So the problem statement why we want to do this is the projects are delivered late and over budget. Okay, that's a problem statement, and I think everybody faces it. Okay, so what's the key variables? The work remaining, the completion rate of the project, and the desired completion rate. And we all know, right? You tell us stuff. Okay, I want you to finish within this week, but actually maybe he can't finish within this week. So the desired completion rate and the actual completion rate is different. Okay, and then obviously, if it cannot finish, then they will have work remaining. Okay? So now, what do you think is the graph? What's the key variables? We have actually three variables, right? Work remaining, desired completion rate, and the actual completion rate. So how does the graph look like? Okay, you can draw yourself. Three variables only, okay? The graph is very simple, right? Three graph. And what this I gave you three variables. So now you can start imagining the system behavior. Work remaining will from top keep coming down over time. It's all respect to time, right? So it's either it's a linear or exponential curve. So the key variables for completion rate depends on how you define, right? Is completion 0% means nothing to do, or completion 100%? So it's this way or that way. You have to decide. Okay. All right. So now we can look at if our projects are delayed, right, what are the options of getting it back on track? Anyone? Resource? What kind of resource? Human resource, headcount. What else? Huh?
We crash the project.
You crash your project. Okay, possible. That means the crash project is how you want to crash a project?
Everybody OT, come early.
OT is a way of crash a project. More headcount, contract staff, right? Contract staff, work overtime. What else? Reduce scope. Okay. Yeah. And what else? Huh? Manage the demand, reduce scope.
Not reduce scope of the project, but that's your capacity.
Ask for a longer time.
You have to manage that it becomes scarce for them.
Manage the client. But the client will say, either I give you more time or
You give a discount to say
or give a discount. Okay, fine. But we want to get the project on time, right? So simple lah. Increase headcount, increase working hours, or OT. Okay, you're all right. But there are other variables that you all can put in, right? Because the more variables means the more we have to map. Start with something simple. Okay. All right. Can you finish this? Can you finish the loop and tell me which one is a balancing loop, which one is a reinforcing loop? You're now bundling, right? There's a real problem. There's a key variables. You identify your solutions, increase headcount, productivity, whatever. Now, model the diagram. Still drawing, still drawing. Once you model, you can plug into the simulation. Yeah, I actually supposed to give you the, I give you the PowerPoint slides. Not, yeah, then you just add. But it's very simple. It can be very complicated, but I expect it to be just very simple. Three things to solve the problem, right? Headcount, OT, and productivity. Complete the loop. Okay, the idea is identify the variable, design the model, and then after that we plug into the simulator. Then we can see what happened. Yeah, well, I mean, you want to have headcount, you must hire, either contract or whatever you must hiring. You must introduce process. Increase the hour works is overtime, right? Increase productivity could be training. You can also say increase productivity like using machine automation. Yeah. That is a policy decision, what you want to do, how you want to solve the problem. Some people say outsource. So is it all reinforcing loop? There must be balance, right? Because we want to bring it to zero, remember? The model, we want to bring it to 0 or 100% completion, right? So it cannot be reinforcing loop. So where are we missing? When you know, modeling, you got to think a little bit, not just plug in the picture and then expect it to happen. Where are we missing? It cannot be purely reinforcing loop. But it must plus, and then it must balance out. Huh? Overtime, finish. So where's the minus? Where's the minus? Yeah, your completion rate, right? To your work remaining. So everything is a balancing loop. But you increase your productivity hour to eventually complete it. And then that is, so all three loops, so you see, this is complicated, right? Because one loop, and then you have another loop, and another loop. It's like all building inside. So three loops all sharing the same completion rate and work remaining. Okay, I'm just showing you the possibilities only. Right? It's up to you to design. So those are things like overtime, training. That's why I say hours work can be overtime, can be contract workers, can be outsourced, right? So that's what we call policy decision. What do you want to do? And then you plug in, then you model. Okay? And then productivity can be training, can be automation, whatever, okay? We can think of. Okay, I think that's about it. I think it's enough complication for the whole morning, right? Okay, so I think when you go back, the first thing what you want to do is model a simple process first before you go into loop. Once you go into loop, sometimes you see a lot of instability. Understand the software, simple process, and then you go into loop. But ultimately, you have to use loop. You have more time, you have less desired completion rate. You can take your time. You got less time, you need higher completion rate. Yeah, the causal factor. You just need to think, is it going the same direction or different direction? Then you know where there's plus minus already. It's how you define that variable. More time remaining, completion rate can be smaller, got more time. Because rate is respect to time. Okay? All right, questions before we break for lunch? Okay, let me summarize, right? The overall system thinking is three things. Holistic, you must look at the whole thing. You must what? You must look at causal factor, right? Causal factor, not correlation, right? What else? And the dynamics, the time, which design thinking don't have. Yeah. So system thinking is dynamics, okay? And then what? And then when you are designing the model, you need to know what? First start with what? Boundaries, system boundaries, and then identify the source and the sink and the variables. Once you identify source, sink, variables, then we identify the causal relationship, positive or negative. Same direction or opposite direction, all right? And after that, then what you do? You have the stock flow diagram, right? You put in everything, then you want to know which one is rate and which one is stock, which one is flow. The simplest way to notice it is to freeze, and then you know which stock is flow, which is stock, right? And after that, what do you do? You need to start modeling, right? But before you start modeling, you need to know the balancing loop and the reinforcement loop, okay? Then you start modeling, right? Key variables, start modeling, and the whole purpose of modeling is reach your objective, and you must know what is your behavior of the system, right? You must guesstimate their behavior of the system, what it works, and then model already, try to use archetypes, because you don't need to think too much. Try to say, oh, okay, if I want to do this behavior, I take this, I just plug it in, right? And after that, throw in the computer simulation, let it run, right? And depends on what simulator you use, you should have a dashboard of all the performance parameter, and then change your, then you can modify your input variables or whatever. That is what we call policy making. It's actually like which one go where, what you want to introduce into the systems, okay? And then you're done. And you simulate until you're happy. That's about it. Okay? Yeah, I try to make it as simple as possible, right? At least half a day you can, I think you will have more satisfaction if you can actually do a small simulator of a process. Yeah, but go back and do lah, huh? Okay? So that's all I have for the morning.